All right, calculus, welcome to video number 3 for our review unit. These are kind of like learning at home here videos for whenever day you are doing the remote part of our class. Anyway, exercises 0.1, that is page 5 in that review unit packet. We have here number 2, solve each inequality. All right, this is a pretty easy one. This is from Algebra 1. Algebra 2, subtract 3 from both sides. When you divide by negative, you know to flip the sign. So x is greater than -2 is one way to write it. We want to get in the fashion of writing things in interval notation. So if x is greater than -2, then x can be anything from -2 to infinity. Always a parenthesis around infinity because all you can do is approach it. The reason there's a parenthesis around -2, again, parenthesis means does not include. The bracket means does include. So this means any number -2 but not including it, so bigger all the way to infinity. Compound inequality here on number 3. Again, this is the question here. I'm going to subtract 2 from both sides. I'm going to divide by -3, thus flipping. Again, you had this literally in chapter 1 in Honors Algebra 2, or Algebra 2 with me. Divide both sides by -3. Now, notice that x is a number between -4/3 and 1/3. Okay, just like that. There's going to be a parenthesis around, I do want you to write it interval notation. There's going to be a parenthesis around -4/3 because it's less than, or x is greater than it. Bracket around 1/3 because technically x can be 1/3. Okay, parenthesis bracket. Number 6, maybe one we didn't talk about a ton in Honors Algebra 2. Hopefully in pre-calculus you talked about it. Here's how you solve it. So first off, we know that, get a different pen in here, x cannot be -2. If you set x equal to -2, you get the vertical asymptote. You did graph those last year with Mr. Jones. Let's figure out it's very important that this is dealing with 0, okay? So find the X intercepts. Okay, that is when the function is 0. Function is 0 for a rational function with the numerator is 0. So set 2x plus 1 equal to 0. You get -1/2. Now, we're going to be doing this a lot this year, especially at the start of the second semester. I want you to make some intervals. So from -infinity to -2, the graph is doing something. Either it's above the x-axis or below it. Again, less than 0 means the graph is below the x-axis. All right, that its y value is less than 0. So from -infinity to -2, it's doing something. Then from -2, the vertical asymptote, to the x-intercept, it's doing something. Then from -infinity, or -1/2 to infinity, the graph is doing something else. So I want you to get in the habit of writing the different intervals out. Test number. What's a number that is in this interval? -infinity to -2. -3 is. What's a number in this interval? -2 to -1/2. -1 is. What's a number that's in this interval? 0. Anytime we can use 0, use 0. So what I'm going to do is I'm going to plug that number into my original rational function there. And I'm going to see, is it less than 0? True or false? So when I plug -3 into that original function, plug -3 up top, down below you get -5 over -1, which is 5. Is 5 less than 0? 5 is not less than 0. So that is not going to be, this interval then is not going to be a part of my answer because it gives my original statement it makes it false, makes my original statement false. So then I'd take -1, and I could have chosen, I guess, -1.5. I could have chosen -0.75. I don't choose -2 because then I divide by 0. Okay, don't choose a number on the outer part here. Don't choose one of those numbers. Choose something in between them. Okay, I'm going to plug -1 up top. I get -1. Plug -1 down below. I get 1. It's -1 divided by 1. It's -1. Is -1 less than 0? It is. True. That means -2 to -1/2 is a part of my solution. See, this is a way to do it without having to graph it, which you won't have the scientific graphing calculator, so you're going to have to do it this way. I would highly recommend it. Plug 0 in. That makes it easy. If you plug 0 in, you get 1/2. Well, 1/2 is 1/2. It's definitely not less than 0. So my single answer, my answer is, when I got the true statement, -2 to -1/2. That is my answer to the interval. All right. Any x value from -2 to -1/2, not including both, will make that function less than 0. Okay, those are more of a challenge, okay? As is number 8 here. All right. So, oh, he's coming down. He might make some noise. This is a parabola, and I want to know, when is the parabola less than 0? When it's its graph below the x-axis. So I'm going to treat it like it says equal to 0, and I'm going to factor it. Well, multiply 6 differs by 5, 6 and 1, 6 is negative. So I have two x-intercepts when x is 6 and x is 1. First off, this is a positive x squared, so my graph makes the u. We did that a lot in Honors Algebra 2. Said, does it make a u? Does it have a min or max? We found the min or max. You did that, I promise, chapter 5. So you can't say, Mr. Jack, I never learned that because I know the exact chapter. I taught it to you. Anyway, there's -1. There's 6. I know it makes a u, okay? Positive x squared. It doesn't matter that, does that, I know what -6 is the y-intercept. When you plug 0 in, that doesn't have to be, to scale. I got something like that. So look at this. I used to teach it by making the same intervals that we did, negative infinity, -1, -1 to 6, 6 to infinity. But because this is a parabola, I know what the graph is. So less than 0, as it says here, means it's below the x-axis. When is the graph below the x-axis? This curve is clearly below the x-axis, between x equals -1 and x equals 6. I have my students shade it like this. Clearly below the graph between x equals -1 and x equals 6. Now, why'd I use parentheses here, not brackets, which might do eventually? Because it's less than. There's no equality. If it was less than or equal to, I would put a bracket around -1 and 6. But the graph is less than 0 between -1 and 6. Now, we might do one where it's greater than 0 sometime. I think actually as a bonus example, we got that. But we will talk about that, obviously, in class. All right, this is from also Chapter 1 in Honors Algebra 2. I described it as, either we were talking about living away from a nuclear blast in Chernobyl or on the track. So I have to live within 4 miles of some place. So I could live to the right of it and closer. Again, I got to be within 4 miles. Or I could live to the left of it or closer. So that means that 2x plus 1 has got to be less than 4. Just like that, I just draw out the absolute value, right? Less than 4. Or, and that's what this is. This is 4 or less. I'm sorry, less than 4. Or 2x plus 1 is greater than -4. Remember, you can live 4 to the right or 4 to the left. That's how you get the +4 and -4. But when you multiply in an absolute, or if you multiply an inequality by negative, you got to flip the sign. Look at the graph. -4 to 0, that means you have a number that is greater than -4. Then you solve both. Okay, x is less than 3 over 2. X is greater than -5 over 2. Can you find a number that is both greater than -2.5 and less than 1.5? Yeah, 0, 1, -2. So it's an in-betweener. X is between those two numbers. There's no equality. We're going to write things in interval notation in calculus. All right. Bonus example. So this one, write this down. This is a bonus example for everybody. Just like the one from number 8. Only greater than or equal to. Again, this is a parabola, y, x is squared. Going to pretend like it's equal to 0. You're going to factor it. X plus 4x minus 2. You got 2 x-intercepts, -4 and 2. It makes a u, positive x squared. With x-intercepts, -4 and 2. Makes a u. This wants to know, when is the graph above the x-axis? Greater than or equal to. So at the x-axis or above. So it's not below the x-axis. It's not that. So the graph is going to continue to go up. It's going to make a curve like that. So any x value from -infinity to -4 will make the graph at the x-axis or above. And then it goes down below. Then any x value from 2 to infinity, because the graph is going to continue to curve up like that. Any x value 2 to infinity means the graph, the y value, will be above 0. All right, the graph's going to be in that first quadrant there, above the x-axis. So my answer would be negative infinity to negative 4. It's above the x-axis. Bracket around negative 4 because it's allowed to be 0. Union means it picks up again from 2 to infinity. Bracket around 2. Again, we'll talk about brackets, parentheses, and union more in actual class. All right. What else we got here? I think that is going to end that video. Folks, this is Yak Math Videos signing out.